Welcome to the Explainer. Today we're going to break down the exact patterns and answers you need to absolutely ace a cloud engineering interview, especially one focused on AWS EKS and Azure DevOps. Think of this as your new cheat sheet.
Okay, let's dive right in. We're going to tackle that classic challenge, the whiteboard test. You have to deploy a production-ready application on EKS using Azure DevOps. Look, it's not just about knowing the tools. It's about proving you've got a solid strategy.
So here's our game plan. We'll start with the EKS foundation itself, then we'll jump over to the Azure DevOps automation engine, and we'll wrap it all up with a production-ready checklist you can take right into your next interview.
First up, let's talk about actually building the Kubernetes cluster. We're going to frame every concept as a direct answer to a common interview question, so you'll be ready for pretty much anything they throw at you.
You know, your very first answer can really set the tone for the entire interview. A simple yes is, well, it's a dead end. But an answer like this, it immediately shows your depth, your context, and your experience. It practically begs for a follow-up question and lets you steer the conversation.
So, when they ask how you'd create an EKS cluster, you lay out the options. You can mention the console for learning, sure, and EKS-CTL for quick and dirty setups. But you always emphasize Terraform as the gold standard for production. And why? Because infrastructure as code is repeatable, it's version-controlled, and frankly, it's the only reliable way to manage serious enterprise environments.
And this right here, this is a key architectural point. You don't just dump everything into one giant Terraform file. No way. You separate your concerns. You have one dedicated module for the network, the VPC, the subnets, all that, and a completely separate module for EKS. This makes your code so much cleaner, way easier to manage, and totally reusable.
They're definitely going to ask you about essential add-ons. And these are the non-negotiables for any real production cluster. You absolutely need the VPC CNI so your pods can get IP addresses and talk to each other. You need the EBS driver for any stateful apps that need persistent storage. And critically, you need the pod identity agent for security and the AWS load balancer controller to actually get traffic into your application. Naming these shows you've built a lot more than just a toy cluster.
And here it is. This is often the make or break security question. It isn't just about Kubernetes. It's about how Kubernetes securely talks to the rest of the AWS ecosystem. Your answer here really shows if you understand modern cloud security. The modern, secure, and correct answer is EKS pod identity. I mean, this is a total game changer. It completely stops you from giving broad permissions to the entire server. Instead, you can assign a very specific IAM role directly to the one individual pod that actually needs it. It's the very definition of least privilege access. And this is how you do it. It's a really clean three-step process. First, you install the agent. Second, you define the permissions you need in IAM, just like you always would. And then third, you create that critical link between the IAM role and a specific Kubernetes service account. It's simple, it's elegant, and most importantly, it's secure.
Now, security doesn't just stop at the pod level. You also have to control access to the Kubernetes API server itself. So be ready to explain the trade-offs between a public endpoint, which you can lock down with IP restrictions, and a fully private endpoint for maximum security, which of course means you have to be inside the VPC to manage the cluster.
Okay, so our secure EKS cluster is all set up and ready to go. Now let's build the CI/CD engine that's going to automatically deploy our applications to it, and we'll do that using Azure DevOps.
Okay, first rule of CI/CD, how do you handle secrets? The answer is never in the pipeline variables. That's just not secure and it's not version controlled. The only production-ready answer is to integrate with a dedicated secrets manager like Azure Key Vault, linking them through variable groups.
This is a classic efficiency question. I mean, in a big monorepo, you don't want to build and test everything on every single commit. That's a huge waste of time and money. The interviewer wants to know if you can build an intelligent, targeted CI process.
Now, what's really cool about this slide is that the answer is right there in the YAML, and it's so elegant and simple. Path-based triggers. You just create a separate pipeline for each microservice, and then you configure its trigger to only fire when a change is detected inside that service's specific folder. That's it.
So, how do you manage all of these different pipelines without just copying and pasting code all day? The answer is templates. This is your key to staying dry, which, stands for don't repeat yourself. You define the core logic for building or deploying one time in a template, and then you just reuse it everywhere. And this pattern, well, this is what brings it all together. This is your playbook for production-grade, multi-environment deployments. You've got separate configurations in your variable groups, one single set of logic in a template, and a main pipeline that uses conditions to decide which environment to deploy to, all based on the branch name. It's really powerful stuff.
Okay, let's bring it all home. We're going to synthesize everything we've talked about into a final checklist of key principles. Seriously, think of this as your cheat sheet for any cloud engineering interview.
For EKS, these are your 5 pillars. First, IAC first. Always use Terraform. Second, secure by default, with pod identity for every single workload. Third, use private access to lock down your cluster's API server. Fourth, you got to go beyond basic metrics with real observability, using tools like Prometheus. And finally, always have a solid, tested plan for cluster upgrades.
And for Azure DevOps, just remember these 5 principles. Centralize your secrets in Key Vault, never in pipeline variables. Optimize your triggers with path filters to save build time and money. Stay dry with templates for all your core deployment logic. Target your build agents intelligently to make sure jobs run on the right machines. And maybe most importantly, code, don't click. Always prefer version-controlled YAML over that classic UI. So, there you have it. You've got the technical patterns. You've got the strategic principles. The final question really isn't for the interviewer, it's for you. With this power to automate and deploy securely, what problem are you going to solve next? Go build something great!